In the past few videos, we have talked about understanding numerical data. In this video, we're going to shift our focus and talk about summarizing and describing categorical data. One common way of summarizing data for two categorical variables is to use a contingency table. A contingency table basically shows the distribution of a variable conditional on values of a second variable. So let's illuminate that a little bit by looking at this example. In this table, we see responses from various college students to the question of whether they're looking for a spouse while they're in college. And we see those responses broken down by the gender of the respondent, whether the respondent was male or female. There were a total of 207 respondents. We can see that number 207 in the lower right-hand corner of the table. Also in the right-hand column, we can see that 137 respondents were female and 70 of the respondents were male. In the bottom row of the table, we can see that 138 respondents answered no, they were not looking for a spouse while they're in college, and 69 respondents answered yes. In the middle of the table, we can see those responses broken out in a little bit finer detail. We can see, for example, that 86 female respondents said they were not looking for a spouse in college, 51 female respondents said they were looking for a spouse while in college, 52 male respondents said they were not looking for a spouse in college, and 18 male respondents said that they were looking for a spouse in college. If you have categorical data, a contingency table is a nice way to get a snapshot of that data, especially if the two categorical variables that you're looking at are ones that you're interested in finding a relationship between. So we could use a contingency table as sort of a first cut at asking a question about whether female students are more likely to be looking for a spouse in college than male students. We will look at another contingency table a little bit later in this lecture and talk a little bit more about what contingency tables can tell us about the relationships between our variables. But before we do that, let's go ahead and look at some graphical representations of categorical data. One really common way of representing categorical variables is to use a bar plot. When you have a single variable, a bar plot shows the frequency with which we see observations in the different categories of our variable. So for example, here what we're looking at is the proportion of female versus male respondents in our data. So in the plot to the left, we're looking at the raw counts of female respondents and male respondents. So we had 137 female respondents and 70 male respondents, and those correspond to the height of the bar. To the right, instead of looking at the raw counts, what we might be interested in is the relative frequency, the relative proportions of those respondents. So for example, in our data set, about 65% of our respondents were female, and about 35% of our respondents are male. So the difference here is what scale the y-axis is on. In the plot to the left, the y-axis just counts up the number of observations in each category, where on the right, what the y-axis is representing is proportion. So while these two plots look really similar to each other, the y-axes on the plots are different, and that gives us different information about the distribution of this categorical variable. You've probably noticed that bar plots can look a lot like histograms, and this is even more obvious when you have more than two categories. So even though bar plots and histograms can look very similar to each other, they do have important differences. So let's go over those differences pretty quickly. The biggest difference between a bar plot and a histogram is that a bar plot is for representing the distribution of categorical data, whereas we use a histogram to represent numerical data. In a bar plot, the labels for each individual column in the plot, they correspond to categories of our data, whereas in a histogram, the labels for each of the columns are corresponding to a value or a range of values of our data. So for a bar plot, we could have a column labeled male and a column labeled female, whereas for a histogram, we're more likely to have a column labeled 0 to 10 and 10 to 20, and so on. In a bar plot, The columns can be in any order on the x-axis, so it doesn't matter in our previous example that female is to the left of male in the plot. We could just as easily reverse those and we would get the same meaning out of the bar plot. In a histogram, the x-axis is numerical, and so it is very important in what order the bins are on the x-axis. So we were just looking at bar plots that showed us the distribution of one of the categorical variables that we were looking at, gender. But what if we want information on both of the categorical variables we were looking at simultaneously? What if we want to look at both gender and responses to that question about whether the student is looking for a spouse while they're in college? A segmented bar plot is a stacked bar plot that can do this for us. So let's look at these two different segmented bar plots in turn. In the bar plot to the left, our y-axis is giving us the raw counts of observations that fall into different categories. So this is giving us pretty similar information to the raw counts in our contingency table. We can see the total number of female respondents, 137. Then we can see a little bit more than 80 of those female respondents answered no to the question, and that part of the bar is in dark blue. And then above that, we can see that the remainder of those 137 participants answered yes to the question, that part of the bar that is in light blue. We can see the similar information in terms of raw counts for the male respondents in the bar to the right. In the segmented bar plot to the right, the y-axis, instead of giving us the raw counts, is going to be able to show us proportion. So in this bar plot, what we're going to be looking at is the proportion of female students who answered yes versus no to that question, and the proportion of male students who answered yes versus no to that question. So in this case, the bars are the same height, even though there are more female respondents than male respondents. The bars are the same height so that we can evaluate the relative proportions of different answers in those two groups. So this bar plot shows us that a little bit more than 60% of female respondents answered no to that question about seeking a spouse in college, and around 75% of the male respondents answered no to that question. So again, the difference in the y-axis is a huge difference between these two plots, and they're giving us different information. The plot on the left is giving us information about raw counts, and the plot on the right is giving us information about proportion. But what if we wanted to capture all of this information, both about proportion and about how many female students there are relative to male students, all in one plot? Well, the next plot that we're going to look at is going to do just that. So let's look at a mosaic plot. This sort of plot might be a little bit harder to interpret at first glance, so let's go through each of the individual bits of information that this plot can give us. Let's start out by looking at the bar to the left of the plot, which represents female respondents. The top part of that bar, which is colored in dark blue, is the female respondents who answered no to the question, are you looking for a spouse while you're in college? And below that, the lighter blue part of that bar represents the proportion of female students who answered yes to that question. Over to the right of that, this bar representing male respondents is going to give us similar information, except for the men. So the dark blue part of the bar represents the male students who answered no to that question, and the smaller, lighter blue box underneath that represents the proportion of male students who answered yes to that question. The final bit of information that we get from a mosaic plot is information about the relative proportion of female versus male respondents in our sample. So in this plot, this corresponds to the width of the bin for the female respondents and the bin for the male respondents. Because we have more female respondents in the sample, the bin for the female column is wider than the bin for the male column. If we had an equal number of female and male respondents in our sample, these bins would be the same width. So those are some common ways of visually representing categorical data. To wrap up this lecture, let's go through another contingency table and talk a little bit about doing inference from a contingency table. So this table is a little bit more complicated than the contingency table that we looked at before. Here we have information on 190 countries in the world, And these 190 countries, for each of them, we have data on two different categorical variables. The first of these is its human security rating from low to high, where the categories are low, medium high, and high. So a high level of human security means that people in that country are very secure from bodily harm. They're less likely to be subject to death from violent causes like war and crime and things like that. A low human security rating means that the people that live in that country are relatively insecure. The other categorical variable is the freedom rating of the country, ranging from free to unfree, where the four categories are free, partly unfree, and unfree. This is a qualitative measure that captures a lot of different dimensions of the concept of political freedom. So these include various civil liberties like freedom of expression and association, a clear and consistent and accountable rule of law, whether the government is fair and accountable, and things like that. So let's go through what we can learn from this contingency table. Let's look at the first row of the table, which represents the countries that are rated as free in this data set. There are 47 of the 190 countries that have this freedom rating. Of those 47 countries, 0 of them have low human security, 1 of them has medium-low human security, 7 of them have medium-high human security, and 39 of them have high human security. So we can see just from this row of data that it seems more likely for a free country to have high human security than low human security. And we can go down and look at each of the rows of our data set the same way, all the way down to the unfree countries, where you can see that 31 of the 47 unfree countries have low human security, 12 of the unfree countries have medium-low human security, 4 have medium-high human security, and none of the unfree countries have high human security. So we have all of this information about these two categorical variables for our set of 190 countries. A research question that we might want to ask is whether there is a relationship between human security and freedom. I want to be clear that we're not going to be able to answer this research question definitively just by looking at the results of this contingency table. We talked, for example, in an earlier video about how things like confounding variables can make it seem like there's a relationship between variables when there's not. So there are all sorts of other things that could be going on here, and a contingency table is only going to give us a pretty rough picture of what's going on in this situation. I've assigned a video for this week from the folks who put together the Open Intro Statistics textbook that's going to go through how we use a process of hypothesis testing to get a better answer to a question about an association between variables like this. But what a contingency table can do for us is it can give us an important hint about whether there might be a relationship between these variables that we could explore further in other research studies. So to do this really basic test, what we're going to do is compare proportions of observations in different categories. So why don't you pause the video and go through these couple of questions from this contingency table. What proportion of free or partly free countries have low levels of human security? What proportion of free or partly free countries have high levels of human security? And then the same questions, except for what proportion of unfree or partly unfree countries have low or high levels of human security. So pause the video and see if you can work those out, and then we'll go ahead and talk about what we can conclude about a possible relationship between human security and freedom. So, of course, we're not comparing across all of the categories in the contingency table because there are so many, because there are 4 categories for human security and 4 categories for freedom. But we're going to use this as sort of a basic test of looking at human security at the really low end and at the really high end. How does that compare, looking at different levels of freedom? So, in answer to this first question, the proportion of free or partly free countries with low levels of human security, We're going to look at this first column for low levels of human security. We see there are 0 free countries with a low level of human security and 0 partly free countries with a low level of human security. So 0% is our answer. Now, in the second question, what proportion of free or partly free countries have a high level of human security? We're going to go over to the far right column underneath the human security heading. We see that there are 39 free countries with high human security and 7 partly free countries with high human security. So that totals up to 46. 46 divided by the total number of free and partly free countries is 46 divided by 95, or 48.4%. So almost half of free or partly free countries have high levels of human security, whereas 0% of them have a low level of human security. On the other hand, when we turn our attention to unfree and partly unfree countries, we're going to see a really different relationship. So there are 16 partly unfree countries and 31 unfree countries with a low level of human security. That is 47 altogether, divided by the total of partly unfree and unfree countries, so 48 plus 47. And we get 47 over 95, comes out to 49.5% of partly free and unfree countries have low levels of human security. But on the other hand, there is only 1 partly unfree country with a high level of human security and no unfree countries with a high level of human security. So 1 over 95 comes out to only 1.1%. So while none of this proves that there's a relationship between human security and freedom, this does give us a pretty good starting point for making an argument that these two things could be really strongly related to each other. The other tools that we're going to talk about over the course of the semester are going to give us better ways of answering research questions like this one, but looking at a contingency table like this can be a good starting point. So that's been our lecture on describing and visualizing categorical data. Please do not neglect to watch the Open Intro Statistics video. That's a case study having to do with gender discrimination and employment. That video is going to introduce some important concepts like hypothesis testing, which we're going to go into a lot more detail about in weeks to come. There may be a question on the quiz that has to do with that video, so don't forget to watch it. Thank you for listening, and I will see you next time.